All right, welcome. My name is Jeff George. I'll be your GPhys instructor. These are some practice problems for units and properties. It's the first part of thermodynamics. We'll be teaching that Monday. I think that's the 21st. I don't remember when that is. June of 2021. So this is for the 2023 class. These are really easy problems, but I want to give you some test-taking techniques. Some useful tips on these problem solvings. Make sure that you don't miss them. When you miss these problems, you'll be missing them in a rush. You'll be missing them so that you can get onto the harder reactor theory questions that you think you're going to have to spend too much time over. So what you do is you gloss over a couple of things that I want to warn you about. There's 5 types of problems in this particular lesson plan. Units and properties of thermodynamics. This will be 2 of the 5. I'll tackle the rest in a couple other videos. What we're going to go over is P2173, which is PWR, question ID number PWR2173. That's what that P means. For boilers, BWRs, they'll be B. So you may see B in parentheses next to some of these questions. 2273 and 2173 are the 2 problems we'll go over here in a minute. 2173 was used on the September 2007 GPhys exam. All these are from previous GPhys exams, if you didn't know that. And looks like the NRC doesn't like this too much, probably because it's a little too straightforward, a little too easy to answer. We're training you to read the question and decipher what the question's asking you, and read the question. When it's just a straight up problem of unit conversions, that makes it a little too easier. They don't like that. So they like to switch around words and make double negatives and stuff. So let's go over how to attack this problem. So the first thing I do, a lot of people tell you read the question first. I don't do that. I look for numbers, right? And look for numbers. There's 16, there's 4, 8, 12, and 14. And I'll look at the units and whether or not they're absolute or vacuum. That makes sense. So right here, I got 16 inches mercury absolute. I got 4, 8, 12, and 14 inches of mercury vacuum. See that? Vacuum, 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 vacuum. All right, that's going to tell me a very important thing, that they want this in inches of mercury vacuum. What do I mean by that is, and I'm going to tell you to do this every time, and you're not going to listen to me, and it's going to bite one of you in the rear end. But here is my advice. Draw a line. When you see a problem like this, draw a line and say, this line represents atmosphere. So we know, you guys all know this, atmosphere is 0 psig. Atmosphere is 14.7 psia. Atmosphere is 29.92 inches of mercury absolute. Atmosphere is 101 kilopascals. It's 1 bar. And a whole lot of other measurement units that I can't remember right now, but that's enough, right? We got inches of mercury. That's the only thing we have in our problem. So the second part of this diagram is going to be down here at the ground, right? What's the ground going to be? Well, it's going to be 0 psia, 0 inches mercury absolute, 0 kilopascals, and 0 bars. However, it's going to be minus 14.7 psig. Okay? And it's also going to be minus 4. We'll go over that in a minute. 0. All right. So what is it given us? It's given a pressure of 16 inches of mercury absolute. All right. Is that above this line of atmosphere, or is that below this line of atmosphere? So we get on our units, right? They're going to be 29.92 is up here. We're looking for 16. What does 16 mean? So 16 is going to be a vacuum, some sort of vacuum, less than atmosphere. So we're going to call it 16 inches mercury abs. Going this way, going that direction is absolute. Okay. What is that in inches of mercury vacuum? Well, what that is trying to ask you is, what is this distance? Because when you go this direction on your diagram, that's going to be inches mercury vacuum. And now seeing that, you're going to go, well, that's pretty easy, right? You just go 29.92 inches mercury absolute. You subtract 16 inches mercury absolute. What do you get? Well, you get 13.92 inches mercury absolute. No. Since we're going down on the scale from here to here, this is going to be inches of mercury vacuum. 13.92 inches of mercury vacuum is my best answer, sir. Circle that, go up 13.92. Now we're looking. So 14. So the NRC is way off, but it's the government, so what do you expect, right? Now, a lot of times they just round up. It's definitely not 12. 12 is a long way away. Definitely not 4, 8, or 12. Good. 14 is the closest answer. I'm going with 14. So I'm looking again. 16 inches of mercury absolute. That means going up on the scale. I can see that right there. And which of the following is the approximate condenser vacuum when the condenser pressure is 16 or 14? Final answer. Delta. Okay. What did I want you to take away from that? These problems, this problem in particular, is very easy, but we saw the ways that we could be tricked. We have to know that when they're talking about PSI vacuum, they mean you are going this way on the scale from atmosphere to nothing, deep space. And we're going to call that vacuum. We're going to call that absolute. Inches mercury. All right, so don't misread. Be careful and diagram every time when we're talking vacuum. That'll save yourself a lot of heartache, man. Don't give up the easy ones. Let's go on to the next problem. This is P2273. This is an oldie. This is was given in the June of 04 test, the June of 2003 test, the October of 2002 test, and the February of 2001 test. I can tell you these problems are really popular, just from my experience dealing with generic fundamentals, because they make you read. This is a sorting problem. Sort from highest to lowest or lowest to highest. They usually have 1, 2, 3 possible answers, and they want you to sort them from lowest to highest or highest to lowest. And it's pretty much always pressure. I don't remember anything with temperature. Actually, there's nothing with temperature. That'd be a little silly. But arrange pressures from lowest to highest. So the way we tackle these is, you guessed it, want to sort from low to high. I would say draw your diagram, but I think first we're going to look at the numbers. Look at the numbers first. And so you got 2 psig, 12 inches mercury absolute, 8 psia, psig, inches mercury absolute, psia. Those two are going to go together somehow because they've got the same units. This is psia, inches mercury. All right, so right there. This is going from psig to psia. And this one's going PSIA to PSIG. All right, so that's what I can tell from reading the answers and the numbers. Okay. Now I'll read the question. Which one of the following is arranged from highest to lowest? Highest pressure to the lowest pressure. So the highest to the lowest. Okay. Not the lowest to the highest to the lowest. So I draw my diagram. Atmosphere. All right, so our 3 units of measurement are going to be PSIG. So that's going to be 0 PSIG. It's going to be 14.7 PSIA, and that's going to be 29.92 inches of mercury absolute. That's at atmosphere, right here. Now, less than atmosphere, it's going to be 0 PSIA, 0 inches of mercury absolute, minus 14.7 PSIG. Oh, wait. Now, we're going from lowest to highest or highest to lowest. Look at that again. Highest to lowest. Highest pressure to lowest pressure. Now you start plugging in where these things are on your diagram. So 2 PSIG, 2 PSIG, 12 PSIA, 12 PSIA. So 12 PSIA is a vacuum because it's less than 14.7 PSIA over here. So 12 PSIA and 2 PSIG, 2 PSIG are over here. 2 PSIG is going to be somewhere up here. 2 PSIG. Yeah, 12 PSA and 2 PSIG. So right here, you can make Charlie and Delta go away. We're looking for highest to lowest. And when you go from 12 PSIA to 2 PSIG, you're going from low to high. Low to high. Charlie and Delta, no good. Now right here, it may be distracting, sorry. Now right here, A and B are your only possible answers. So I haven't even done any equations. I haven't done any railroad tracks. I haven't done anything. I'm just thinking through this. All right. So highest to lowest, we're going to start at 2 PSIG. So that's good. There's only 2 possible answers. We're going to go to 12 and 18 inches of mercury absolute. So inches of mercury absolute, they're both going to be less than 29.92. So there's 12 and there's 18. And those are inches. I'm not going to lose the mercury just for space sake. All right, so there's 12, there's 18. Now we got to find 8 PSIA. Well, 8 PSIA is going to be less than 14.7. So where on this scale is 8 PSIA? That is the question. So before we convert from PSIA to inches of mercury absolute, which we can do, but why do math when you don't have to? Let's see if we can figure this out. So we start at 2, the high. We go to 8 PSIA, the low. 2 PSIG is the high, 8 PSIA is the low. So both of these answers, to get the correct one, 12 and 18 are going to have to be between 8 PSIA and 2 PSIG. Maybe they are, maybe they aren't, but the answer's not going to work if they're not. So just assume they are. I won't even bother looking up what 8 PSIA is compared to inches of mercury absolute. I don't have to. I know it's lower because the answer is going to be the lowest. Going from highest to lowest. If we go from 2 to 18 to 8 PSIA, 2 PSIG to 18 inches of mercury absolute to 8 PSIA, that would be higher than 2 PSIG to 12 inches of mercury absolute to 8 PSIA. So I'm going to say the 12 is no good. And I mark that down right like that. I have figured out this problem. The answer is B. without doing any unit conversions by using my diagram. There's a chance that A could be the right answer, but it just doesn't make any sense because 18 is more. So you're going from the highest to the lowest. Which one of the following is arranged from highest to the lowest, H to L? 2 psigs up there, 8 psia is down here. Somewhere in between is 12 and 18 inches of mercury. Charlie and Delta are going from lowest to highest, so I know they're not right. And now I've answered this question. All right. So what did I want you to get out of this demonstration, right? So units are very important. First, numbers. Units, specifically vacuum, vacuum somewhere, VACUUM, absolute, right? Diagram. Once you draw on that diagram, you will miss this if you don't. And then read the question, like highest to lowest, lowest to highest, and eliminate possible distractors if you can, which we did with 3. So the distractor elimination, right? I hope you've enjoyed this. I hope you got something out of it. Thanks for watching. We'll see you in class.